In this session we want to learn how to train a model, in order to recognize hate speech sentences, posts, or tweets. What we do is use a dataset containing some tweets along with their classification. We have two files, the first is for training and another file for examining the correctness of the trained model. As we see, the files are CSV. If we open them, we will see that there are three columns: ID, label, and tweet. The first column is not essential. The second column shows if the tweet is a hate speech tweet by one. Usernames have been deleted from the dataset and replaced with user. For instance, this is a hate speech tweet. Also this one. The point that should be known is that in order to teach the model to recognize hate speech tweets, the model needs to see both hate speech and regular tweets simultaneously. You can design your own dataset and label each tweet that you think is a hate speech. Note that the test file doesn't have the label column because the model itself should guess this column. Create a new file and save it in the desired directory. Import pandas, re, and other necessary modules. We use the resample to balance the dataset. The resample method makes more data for the training process. Next, import df-idf vectorizer. You can also import count vectorizer, and use it as a replacement for tf-idf. The difference between tf-idf vectorizer and df-idf transformer is that we can do vectorization in a more concise way, by using vectorizer. Next we import the SGD classification. Using this method, we train our model. Open the train and test file using pandas and the read_CSV method. Then you can print the number of tweets for the train as well as for the test. The shape method prints the number of rows and columns, respectively. Execute the code. As you can see, we have 31,962 tweets for training, and 17,197 tweets for testing. We define a function to delete additional information, such as usernames. We do this using regular expressions. Tweet field is the name of the column, which here is equal to tweet. Using apply, you can run a function on all tweets. Finally, return the data frame. Next, we set the train with tweets. Do the same for the test. Run the code again to make sure it works. Sub requires 3 arguments. As you can see, there are still meaningless characters in the tweets. Now run the code again. Here we want to balance the dataset to have more training data. As you can see, a new 29,720 row has been created, that we need to add to the main training data. Next, we use pipeline to set all the parameters for training. Next, we split our data using train test split. Then we start using the fit training method. Next, we can check our tweets using the predict method. Fix the error and run again. As you can see, the list of numbers is displayed. Then enter F-score in the program. Using F-score, we can see how well the model works. If we multiply the obtained number by 100, the result is printed as a percentage in the output. As you can see, the model answered 96% correctly using the tests we performed. Note that this number is random because the data we select for testing is randomly selected. Next, we want to run the model on a few sentences and check the output. In the next session we will learn how to save the model, and also test the model on our tweets, and compare the results. The predict method takes a list of sentences, and returns a list of numbers consisting of 0 and 1. 0 means that the tweet is a regular tweet, and 1 means that the model identified the tweet as a hate speech tweet. Open the file and copy a tweet. This tweet is known in the dataset as a hate speech. As you can see, the model worked well and detected the tweet. We add another sentence to the list. As you can see, It recognized this sentence as a normal sentence. The point is, you can use this to do a lot of other things. For example, you can have a list of sentences that are positively and negatively classified. Then save them in a CSV file and run the model on the dataset. Finally, you can use predict to check the positive and negative sentences. In fact, by doing this, you have designed your own sentiment analysis.